I'm gonna okay, so I'm gonna look at this with you as we continue. We are looking at the angle addition postulate. You guys took a quiz yesterday, right? Okay, what was that postulate that was about taking this little segment and the next segment and adding them up and getting the big segment? What was it called? Segment addition postulate. Do you remember that?
Yeah, I got that wrong.
Okay, so that was similar to this idea that we're about to look at, okay? So, and I also told you about that the day before, right? Do y'all remember I told you need to know this? Did you forgot? Yeah. You forgot? Okay, so today we're gonna look at a similar postulate for angles, okay? Now, before we go any further, what is a postulate? It's
The law that can,
It's a law that can't be proven or
or it's accepted without.
accepted without evidence. I like that.
I feel like this is something we need to know if you ask this.
Okay, a postulate was one of our original vocabularies, okay? Geometry is based on ideas that are kind of understood to be true, and then you build from that. And so those are postulates. One of those postulates was that you can take two little segments that are on a line and add them to get a longer piece on that line. We used that when we did M is between A and B, and we drew those pictures and labeled the parts and wrote all those equations. When you're doing that, you're doing the segment addition postulate, okay? So what you're looking at here is similar. This is the angle addition postulate, which means that you have an arc or an opening, and then you're adding another opening to it and getting a larger opening, okay? Such as if I go to this door and I open it to that far, I created an angle. If I go to this far and I added that much to it, I have now created a very much larger angle. That's the angle addition postulate. It's understood that if you have an opening and you add another opening, you get a larger opening. That's what the angle addition postulate says. Okay, so with that said, let's look at our page. I asked you to kind of read through this. Two angles are congruent when they have the same measure. Angle A and angle B are congruent angles. If those are congruent, the measure of angle A is equal to the measure of angle B. So this notation that you see is actually saying the amount for that angle is equal to the amount for that angle, okay? Where this is saying these angles are congruent. They are congruent things. Angle A and angle B are their names. We've already talked about that a little bit, right? Okay, so with that said, we're going to use the angle addition postulate and really notate these things correctly with this measure or this angle symbol. And you might say, she keeps going on and on about that, but we're not doing it. That's going to become important when we start writing proofs, okay? That notation. So we're kind of trying to get there. So look with me at the angle addition postulate. In words, if angle P is in the interior of angle RST, that's the name of this big angle, then the measure of angle RST is equal to the sum of the measures of angle RSP. Well, let's kind of highlight that because it's just a lot of letters. And angle PST, which is this one. And so basically in symbols, this is this nice statement. P is in the interior of the big angle. So the measure of the large angle is equal to the measure of the small angle plus the measure of the other small angle. That's what that's saying. So this is a whole lot of notation, okay? So before I go any further, if I were to give you this angle, okay, this is not the degree measure because it doesn't have a degree symbol behind it. It's actually the name of an angle. Angles can sometimes be named with numbers. You actually don't have any like that on your paper, but that'll show up in the textbook. So if I were to tell you to name that multiple ways, what can I call it?
RSN and.
Okay, so angle R, can I call it RSM?
No.
No, RSM would be this, right? So you can't call it that. Angle R what? MS. So that middle letter has to be M. Angle SMR. What else? Angle 2. And in this angle, I can call it angle M, but only because there's no other point angle formed there. You see the difference in that and that? This you cannot call angle S. Does that make sense? You see how angle S would be very unclear? Okay, so you may see it like that, okay, where you're having to name some things. Let's keep going. Okay, so we're using this idea that two smaller angles add up to the larger angle when there's a point and they're connected. Okay, so looking at this example, we're going to do something like this very shortly. You were given here the measure of angle QPS is 157. Look at your picture. That is not labeled, okay? Find the measure of angle QPR and the measure of angle RPS. So those angles are labeled with something, and the diagram has some expressions in terms of X, okay? So this one's all worked out for you nicely, but I'm going to kind of talk with you about something. As you did this, this could be labeled like this. Angle QPS is the large opening. Label it 157 degrees. That's how you show that overlap with angles, okay? When you do that, it makes it really obvious that this part plus this part is equal to the big part, and that's where this equation comes from. Does that make sense? Okay, so when we do that, we are applying the angle addition postulate. That's going to come into play quite a bit when we get into proofs. We'll have to know the names of these things, okay? Now, at that point, you are saying this is this angle from the picture. QPR is this angle. RPS is this angle, and you're plugging those things in, and then you're just doing the algebra to solve. Does that make sense? So we're combining like terms, we're adding 5 to each side, we're getting dividing by 6, we're getting X. Okay, once we get X, we're just going back and plugging in to find the values, just like we did when we did segments. That makes sense? Okay, so that's what you're gonna be working on today. Okay, so make sure when you're notating the measure of an angle that you're putting this little M in front of the angle. That's the correct notation. So in the end, the measure of angle QPR is 121. The measure of angle RPS is 36. That's kind of how that works, okay? So what is that postulate called where you can add two small angles and get a large angle? Angle addition postulate. Okay, so if you go on to the next page, you're going to see something called an angle bisector. We also worked with segment bisectors, right? Okay, so an angle bisector is a ray that divides an angle into two angles that are congruent. So if you look at this picture over here, it says ray YW bisects angle XYZ. Now that means that it cuts that angle into two congruent pieces. Notice the marks. For marking things congruent on angles, we use arcs.
Are they in the line? It looks the same.
So this would be an arc, that would be an arc. What's your question?
Or why aren't they like? So like the YWC arc is lower, like closer to the inside of the angle than the XW.
YWZ, you mean WY?
Yeah, but the arc is.
The big thing that matters is that you use the same number of curves, okay? So sometimes you'll have double marks, sometimes you'll have triple marks, okay? So I think they were drawn closer together, but it doesn't really matter. You're marking it with one arc. Okay, that makes sense? Okay, so the arcs are there only because the description said the ray bisects the angle. So this word bisects, it means it cuts it in half, right? Two congruent pieces. Okay, so with that said, if you had a problem like this, using a bisector to find the measure of angles, okay? BD bisects angle ABC. That is telling me that those things are congruent. And the measure of angle ABD is 35. You notice it's labeled, you notice the marks. So because this is true, we can easily say if that's 35, this is 35. And when I find the answer, angle ABC would be 35 plus 35, which is 70. And that's actually using the angle addition postulate. Does that make sense? Okay, so you've got a couple of ideas here. A bisector, an angle addition postulate. Okay, so I'm going to give you a couple minutes. I want you to try problems 1 through 5. Okay. Let me just read them with you, and then we'll kind of try them. All right, number 1, name 3 different angles in the diagram. Write your answers on your paper and pencil. We'll make corrections. Okay, you're going on through this, trying to do 1 through 5. On number 1, you should have, can I call something angle Q?
No.
No, I've got too many things involving that, right? Okay, so on the first one, we should have PQR, yes? Yes. Okay, all right, let me just kind of go around. Polly, give me another angle for that name.
RQP.
Angle RQP
Yes.
is the same as this one, okay?
Oh, sorry.
That's okay. Angle what?
RSQ. Wait, RQS.
RQS, and that's important, right? Good. Okay, all right, Blake, give me another one. PQS. Angle PQS is the other one, right? Thank you. Okay, let's go on to this. Nate? I want angle COA. What did you get?
110 degrees, and it's about 2.
It's 110. Where'd that come from?
Seeing the 160 and the 50, and I subtract the 50 from the 160. Right,
So you're using that number and that number?
yeah, I'm using the inside.
The inside scale. Can you use the outside scale?
Yes.
You can use either one. You're getting 110?
Yes.
Everybody agree? And it's off 2? Okay, so this is 110 degrees. Okay, let's go on over to this one. I want angle BAD. Cooper, what'd you get?
On which one?
BAD, measure of angle BAD, number 3.
55.
55. What's the name of the postulate that lets us do that?
Angle addition.
Angle addition postulate, right? Good job. All right, this is a straight angle, and we were able to write an equation, James. How do you write an equation?
6x minus 18 equals 180.
Okay, so you went ahead and added these together, and that's okay. Some of you may not have done that, but this is completely fine, what he said. Everybody comfortable? Everybody comfortable? All right, solving that out, James,
Yes.
What are you doing?
I'm finishing up.
Finish it up. Tell me what you get. 6x equals,
Got 6x? Oh, 6x equals 108.
x equals,
33.
okay. And now I want the measure of angle FGH.
132. Okay. FGH.
How do you get that?
Multiplying it by 4 because it's 4x.
Everybody comfortable?
Yeah.
All right, we're good there. Now, on the last one, you would draw a picture. If FH bisects angle EFG, if you haven't drawn that picture, draw that picture. Okay? James, are you using a calculator? You don't need a calculator.
So you do. So then what you 198 by 6.
Okay, drawing your picture. Have you drawn your picture? Yes? Okay, so on number 5, you're gonna draw angle EFG, draw the angle, label it, draw it. Yeah. All right. Okay. So you started by drawing an angle, right? And you put the letters around it like you're supposed to label it, right? Okay, so you went like this. E, F, G. E, F, G. F, H bisects E, F, G. Oh, did everybody draw okay?
No, I got you.
So you got sort of H right here, right? What else can I put on my figure?
45 degrees on
42. E, F, H, 42, so you can put that there. What else can you put on your figure? You can, but you can also mark it like this. Okay, remember that's what that means. Does that make sense? All right, now I want the measure of angle GFH. GFH. GFH 42. Is that right? 42. So this is 42 degrees. Okay. And then I want the measure of angle EFG, right? 84. 84 degrees. So that kind of gives you the main ideas of what we're working with today. Okay. Go ahead and take out a piece of number paper. Okay. We're going to start your homework assignment, which is from section 1.5 in the text. So you're going to need a piece of number paper and your text. Okay. In a few minutes.
Okay.
Okay, at the top of your notebook paper, go ahead and write down today's assignment. We're actually going to do the last part of class working. So you're going to write down at the top of your page, number 7, on the top line of a clean sheet of paper. Page 41 to 43. You're doing all odds, these are all odds, 139 odd. 27 odd, 31, 43 odd, and 49. Okay? So everybody set that up, get your book and get started. You should get quite a bit done. We got a few minutes finally. And you don't say very well.
I don't have my comment. Okay, 143. That is.
Okay, we're starting our assignment. So your textbook, the clean sheet of paper, assignment number 7 over there. Let's do it, all right, we can work on it right now.
Yeah, question.
Yes. Don't lock yourself out, make it quick.
Okay.
Okay, can everybody see that, okay? Yeah, like we did that other one where you had to use all the letters.
Oh,
You know,
like,
does that make sense?
that's classified.
When it was like classify or describe.
Okay.
Okay, that makes sense.
Yes.
Okay, is everybody comfortable? All right, let's get started. Our first test is next Wednesday, September 4th. Okay, just a little upcoming announcement there. We are out Monday, so we'll come back Tuesday and review everything we've done and have a test Wednesday. So you know what's coming.